So my name is Sheetal. I'm from India. I'm at a university, and my topic is the artificial neural network approaches for the wastewater treatment via the biochar. So one of the world major issue today is the massive pollution released into the environment due to the rapidly expanding industrials and the agricultural waste. More than 77 lakh around to 1 lakh dyes are reportedly created each year from the varieties of the industrial process. So there are many industries in the world like textile industries, plastic, cosmetic, and food processing industries. These are related to these are also containing hazardous chemicals and produce different types of the uh, different types of the chemicals in the environment. And there are many types of dyes like synthetic dyes, cationic dyes, and anionic dyes. So dyes disposal into the environment is a detrimental effect both life like aquatic life and the human life as well. And the effects can take the shape of the cosmetic problems such as like water that is discolored and smell bad, as well as the death of the aquatic system as well as the human beings also because of the reduced sunlight penetrations and decreased oxygen level into the water. So in this study, I have used already a crystal violet dyes that is basically used in the textile industries and which is used to color and finish the fabric. So to remove the color, a variety of wastewater treatment techniques were used, including membrane filtrations, ion exchange coagulations, and advanced oxidation procedure also. But in this study, we have used a bioabsorption technique that is very easy and very cost-effective technique for the wastewater treatment. But there are many drawbacks of this process, like the chemical requirement, residual metal stop solubility, costly capital expenditures, high operating cost, and high sludge formation. But the bioabsorption process is a very viable method for the processing and treating as well as the treating wastewater and maintaining a very high level of crystal wallet for removal efficiency. So this is the procedure of the bioabsorption procedure. You can use any bioabsorbent for the removal of the dyes, heavy metals, and metalloid also. So these are the absorbent, and these are the some functional group. Your functional group may be a carboxylic functional group, hydroxide functional groups, so many functional group which is binds to the carb adsorbent and provide the removal efficiency for the dyes, heavy metals, and metalloids. There are three boundaries. First is your boundary layer, and second is your intraparticle diffusion layer, and third one is your the interactions between the pollutant and the solvent. So these are basically the example of the interactions like electrostatic interactions takes place, ion exchange, chelations, precipitations, hydrogen bonding. It also takes place between the pollutants and solvents. Enzymatic activities also takes place, redox mechanism also. So there are many activities and many interactions and mechanism takes place in the bioabsorption process. But the efficiency of the bioabsorption process is very good, even very efficient method. This is very efficient method. Next is there are numerous material that is made from the agriculture waste, and we make a biochar that is made up of various agriculture waste. Your agriculture waste may be a rice, maybe a wheat, maybe any food waste, and because this is very cost effective and this is a biodegradable material and a renewable resources also. But in recent study, we have concentrated on improving the bioabsorption process and discovering dye removal adsorbent that is very economically effective and ecologically material. So a biochar is a very low cost adsorbent, and in the study we have used a biochar for the productions of the porous adsorbent to remove the crystal violet dye from the wastewater. And my biochar is a very good option in the context of the circular economy, because the call of the utilization and recycling of the organic waste, this is very best option for this problem. And we have used two techniques in this study. First is the RSM and second is the machine learning. RSM is your response surface methodology, and machine learning, basically we use ANN, artificial neural network machine learning, to optimize the conditions for the wastewater treatment. Basically, in the RSM, we have to identify the operating conditions for a system, and explain how these ideal conditions affect the response. So basically, we have collect three inputs, 3 to 4 man. It's depend on you. Uh, and to determine effective parameters with the few numbers of the possible test, and investigate the interactions between the parameters and the to find out the design, and to make the model under the RSM that is utilized as a experimental design. And your ANN is the artificial neural network. This is a very improved network model on the way of the human brain works. And ANN provide a linear or non-linear modeling between the output and the input without any prior knowledge. So your input may be your independent variable, and your output may be your dependent variable. So there is a link between the output and input layer, which is artificially neural is placed, and provide a very optimized conditions for, and provide a very connections and interactions, and a curve and a fitting curve, and a correlation coefficient provided by the ANN. So this is the method. In this method, we use a crystal wallet dye, and to modify the acidity and basicity, used a nitric acid and sodium hydroxide used. And basically, we can make a biochar with the help of pyrolysis method. And this is the RSM procedure. We have make some stock solution with the different conditions, and after that we have after that we have make a different concentration solution. We have put into the incubator for at least 1 hour, a different RPM level, and find out the result. There is around 93 to 95% removal from this RSM process. We have used a different input like temperature, different concentrations, and different time, and different dose also. These are the parameters. So this is the batch study process. We have used around adsorbent dose around 0.25 to 0.25 milligram, and dye concentration we have used 10 to 50 milligram per liter. And we have also used a pH 4 to 8, and different temperature like 15 to 35 degrees Celsius. After we have completed the procedure, we have find out the bioabsorption equilibrium readings with the help of the spectrophotometer at the 664 nanometer. So these are the some coded values. These are the some coded values. With the help of these coded value, we have find out the efficiency, and find out the removal efficiency of the wastewater treatment with the help of biochar. So this is the result of the RSM optimized condition. You can see this in the slide. There are some input parameters. So in this slide, we have 4 parameters: the dose, and temperature, pH, and some concentration also. These are the actual values and predicted values with the help of this batch process. So you can see the maximum around is 93.83 removal efficiency we have find out. from this method. So you can say that adsorption and bioabsorption is a very cheap and easy to use method, provide a very good efficiency for the removal of the wastewater treatment. So these are the 3D plots of the RSM methods. RSM methods. So you can see there are some interactions between the pH and dye concentrations, temperature and dose, between the temperature and dose. So if you have increased the dose, increase the dose concentration, your removal is also increased. If you have the concentrations of the solution increase, your removal may be decreased. So the input parameter is also is an important factor for this study, because your removal efficiency is depends on your the input parameter. So your input parameter may be a pH, your dye concentrations, maybe a dose, or maybe a dye temperature. So the input temperature is a very important factor for this study. You have to maintain all the pH, temperature, and dye concentration for this study. After that, we also apply a ANN study, that is a artificial neural network. This is the artificial neural network study. So these are the, in your left hand side, these are the some input parameters, and your this is your dye removal is your output parameters. So there is only one output, that is your dye removal, and we have apply a hidden layer, that is your Lobsys method. And in this study in this study we have there are 30 inputs and design parameters are including, and we have analyzed the training, validations, and testing models also. So ANN are used to generate a new process and analyzing existing one and participate the result performance of the system. That is a feed forward neural network that is optimize the conditions of the input and create a topology between the input, output, and a hidden layer. So this experimenter is designed by the CCD, Composite Central Design. We provided the input and output for training, and log sigmoid transfer function is also used, and they provide the necessary informations for anticipating the outcome. So these are the figures, and these are the expected value of the ANN model. You can see the R's value is your 0.97, 0.969899. So it's indicate that your model is a valid, and the accuracy of the model is very good. So this is the result of this study. So there are some optimal projected CV removal value is the 95%, and the actual is the 95.1% with this input conditions. And this is the equations that proves that the dye removal efficiency, and the R square value is the 0.9216. This is the graph between the actual and the predicted value. So this is the table that figure out the difference, that shows the conditions between the RSM and ANN prediction. So the RSM prediction is 94.18%, and the validation experiment shows the 95.51%, and the ANN predictions shows the 96.85%. So according to this study, so ANN model is better. You can say that the ANN model is better than the RSM modeling, because there are a minute around 2% difference between the RSM and ANN predictions, but ANN is better as compared to the RSM model. After that, in this bioabsorption process, the optimize is frequently used to remove the efficiency of the CV dye removal percentage. And the efficacy of RSM study is also predict, and the ANN study is also predict. But the biochar was presented a very highly effective bioabsorbent and used to remove the crystal violet from the aqueous solution. The procedure was optimized utilizing a minimum number of the high precision experiment using a CCD techniques, and the highest removal of the influence the temperature factor like temperature, dose, dye concentration, pH is also investigated. And the key aspects of the study is the minimum adsorbent consumptions and rapid extractions, use of environment acceptable absorbent and adsorption capacity. So the eliminations of the poisonous dyes, mostly industrial scale, can undergo a resolutions, and because of the use of the expensive agriculture waste material as a biodiesel. So you can say that biochar is a very cost effective and a very easy to use, and is a environmental friendly material as a adsorbent for the removal of the wastewater treatment. See, these are the references, and I have one publication regarding the study in Nature Scientific Report. And thank you.